The LAVIE, high-quality video generation with cascaded latent diffusion models. This work aims to learn a high-quality text-to-video generative model by leveraging a pre-trained text-to-image model as a basis. It is a highly desirable yet challenging task to simultaneously accomplish the synthesis of visually realistic and temporally coherent videos while preserving the strong creative generation nature of the pre-trained text-to-image model. To this end, we propose LAVIE, an integrated video generation framework that operates on cascaded video latent diffusion models, comprising a base text-to-video model, a temporal interpolation model, and a video super-resolution model. Our key insights are twofold. 1. We reveal that the incorporation of simple temporal self-attentions, coupled with rotary positional encoding, adequately captures the temporal correlations inherent in video data. 2. Additionally, we validate that the process of joint image-video fine-tuning plays a pivotal role in producing high-quality and creative outcomes. To enhance the performance of LAVIE, we contribute a comprehensive and diverse video dataset named Vimeo 25M, consisting of 25 million text-video pairs that prioritize quality, diversity, and aesthetic appeal. Extensive experiments demonstrate that LAVIE achieves state-of-the-art performance both quantitatively and qualitatively. Furthermore, we showcase the versatility of pre-trained LAVIE models in various long video generation and personalized video synthesis applications. QA-LoRA, Quantization-Aware low-rank adaptation of large language models. Recently, years have witnessed a rapid development of large language models, LLMs. Despite the strong ability in many language understanding tasks, the heavy computational burden largely restricts the application of LLMs, especially when one needs to deploy them onto edge devices. In this paper, we propose a quantization-aware low-rank adaptation, QA-LoRA algorithm. The motivation lies in the imbalanced degrees of freedom of quantization and adaptation, and the solution is to use groupwise operators which increase the degree of freedom of quantization, meanwhile decreasing that of adaptation. QA-LoRA is easily implemented with a few lines of code, and it equips the original LoRA with twofold abilities. During fine-tuning, the LLM's weights are quantized, for example into INT4, to reduce time and memory usage. 2. After fine-tuning, the LLM and auxiliary weights are naturally integrated into a quantized model without loss of accuracy. We apply QA-LoRA to the Llama and Llama 2 model families and validate its effectiveness in different fine-tuning datasets and downstream scenarios. Code will be made available at the project's website. Aligning large multimodal models with factually augmented RLHF. Large multimodal models, LMM, are built across modalities, and the misalignment between two modalities can result in hallucination, generating textual outputs that are not grounded by the multimodal information in context. To address the multimodal misalignment issue, we adapt the reinforcement learning from human feedback, RLHF, from the text domain to the task of vision-language alignment, where human annotators are asked to compare two responses and pinpoint the more hallucinated one, and the vision-language model is trained to maximize the simulated human rewards. We propose a new alignment algorithm called Factually Augmented RLHF that augments the reward model with additional factual information, such as image captions and ground truth multi-choice options, which alleviates the reward hacking phenomenon in RLHF and further improves the performance. We also enhance the GPT-4 generated training data for vision instruction tuning with previously available human-written image-text pairs to improve the general capabilities of our model. To evaluate the proposed approach in real-world scenarios, we develop a new evaluation benchmark, MMHAL bench, with a special focus on penalizing hallucinations. As the first LMM trained with RLHF, our approach achieves remarkable improvement on the LAVA bench dataset with the 94% performance level of the text-only GPT-4, while previous best methods can only achieve the 87% level, and an improvement by 60% on MHAL bench over other baselines. We open source our code model data at project's website. VideoDirectorGPT, consistent multi-scene video generation via LLM-guided planning. Although recent text-to-video (T2V) generation methods have seen significant advancements, most of these works focus on producing short video clips of a single event with a single background, that is, single-scene videos. Meanwhile, recent large language models, LLMs, have demonstrated their capability in generating layouts and programs to control downstream visual modules, such as image generation models. This raises an important question. Can we leverage the knowledge embedded in these LLMs for temporally consistent long video generation? In this paper, we propose VideoDirectorGPT, a novel framework for consistent multi-scene video generation that uses the knowledge of LLMs for video content planning and grounded video generation. Specifically, given a single text prompt, we first ask our video planner LLM, GPT-4, to expand it into a video plan, which involves generating the scene descriptions, the entities with their respective layouts, the background for each scene, and consistency groupings of the entities and backgrounds. Next, guided by this output from the video planner, our video generator Layout2Vid has explicit control over spatial layouts and can maintain temporal consistency of entities' backgrounds across scenes, while only trained with image-level annotations. Our experiments demonstrate that VideoDirectorGPT framework substantially improves layout and movement control in both single and multi-scene video generation, and can generate multi-scene videos with visual consistency across scenes, while achieving competitive performance with SOTAs in open-domain single-scene T2V generation. We also demonstrate that our framework can dynamically control the strength for layout guidance and can also generate videos with user-provided images. We hope our framework can inspire future work on better integrating the planning ability of LLMs into consistent long video generation. Attention Satisfies, a constraint-satisfaction lens on factual errors of language models. We investigate the internal behavior of transformer-based large language models, LLMs, when they generate factually incorrect text. We propose modeling factual queries as constraint satisfaction problems and use this framework to investigate how the model interacts internally with factual constraints. Specifically, we discover a strong positive relation between the model's attention to constraint tokens and the factual accuracy of its responses. In our curated suite of 11 datasets with over 40,000 prompts, we study the task of predicting factual errors with the Llama 2 family across all scales, 7B, 13B, 70B. We propose SAT Probe, a method probing self-attention patterns that can predict constraint satisfaction and factual errors and allows early error identification. The approach and findings demonstrate how using the mechanistic understanding of factuality in LLMs can enhance reliability. DeepSpeed, Ulysses, system optimizations for enabling training of extreme long-sequence transformer models. Computation in a typical transformer-based large language model, LLM, can be characterized by batch size, hidden dimension, number of layers, and sequence length. Until now, system works for accelerating LLM training have focused on the first three dimensions: data parallelism for batch size, tensor parallelism for hidden size, and pipeline parallelism for model depth or layers. These widely studied forms of parallelism are not targeted or optimized for long-sequence transformer models. Given practical application needs for long-sequence LLM, renewed attentions are being drawn to sequence parallelism. However, existing works in sequence parallelism are constrained by memory communication inefficiency, limiting their scalability to long-sequence large models. In this work, we introduce DeepSpeed Ulysses, a novel, portable, and effective methodology for enabling highly efficient and scalable LLM training with extremely long sequence length. DeepSpeed Ulysses at its core partitions input data along the sequence dimension and employs an efficient all-to-all collective communication for attention computation. Theoretical communication analysis shows that whereas other methods incur communication overhead as sequence length increases, DeepSpeed Ulysses maintains constant communication volume when sequence length and compute devices are increased proportionally. Furthermore, experimental evaluations show that DeepSpeed Ulysses trains 2.5x faster with 4x longer sequence length than the existing method SOTA baseline. Efficient post-training quantization with FP8 formats. Recent advances in deep learning methods such as LLMs and diffusion models have created a need for improved quantization methods that can meet the computational demands of these modern architectures while maintaining accuracy. Towards this goal, we study the advantages of FP8 data formats for post-training quantization across 75 unique network architectures covering a wide range of tasks, including machine translation, language modeling, text generation, image classification, generation, and segmentation. We examine 3 different FP8 representations, E5M2, E4M3, and E3M4, to study the effects of varying degrees of trade-off between dynamic range and precision on model accuracy. Based on our extensive study, we developed a quantization workflow that generalizes across different network architectures. Our empirical results show that FP8 formats outperform INT8 in multiple aspects, including workload coverage, 92.64% versus 65.87%, model accuracy, and suitability for a broader range of operations. Furthermore, our findings suggest that E4M3 is better suited for NLP models, whereas E3M4 performs marginally better than E4M3 on computer vision tasks. The code is publicly available on Intel Neural Compressor project's website.